Okay, sorry for this delay, for these problems. So shortly about FLEXYNETS. FLEXYNETS is a small Horizon 2020 project that has to do with what we call fifth generation low temperature district heating and cooling networks. The partnership is also very small for usual Horizon 2020 partners, with a couple of partners by academy, us, URAC, and the Hochschule Stuttgart, and with the other 4 partners from industry, from different industrial sectors, from renewables to control to planning of district heating networks. Why we call the kind of networks we work on fifth generation is because, on the one hand, one of the topics, one of the specific objectives we are working on is to reduce the transportation losses as much as possible. And again, to do this, what we are studying is networks that operate in between 10 and 25 degrees C of the distribution medium, which is water for us. We will see different approaches in the next presentations. And again, what we are doing compared to traditional networks, but also with respect to fourth generation networks, is to look into how to integrate multiple energy generation sources. Not only few, for example, industrial waste heat, or specific sources like in fourth generation solutions, but as many as possible generations, both coming from waste heat and renewables. The other main topic we are working on is how to exploit the thermal capacity of the network, both in terms of the water and therefore in inertia that is included into the pipelines, but also by using say thermal storages that are say set up at central level, like large storage pits that are normally used for example in solar district heating networks, like in Denmark, as you if you know the solution. But also looking into decentralized local local storages that are set up in each of the customers' buildings. As you can imagine, as we use transportation, a transportation medium that is at these neutral temperatures, as we call them, we cannot use it. We cannot use the thermal energy directly into the customer site, but we need, say, heat pumps, basically to rise the temperature from the network temperature to the user's useful and comfort temperatures. And then again, if we couple all these issues together, so multiple energy generation, storage capacity, heat pumps all together, you can understand that the main focus of the project then comes onto the control strategy, onto how to manage the network itself in a proper way. From the approach point of view, we didn't invent really something new. We have taken from the water loop concept that is quite a state-of-the-art in the tertiary and in the retail sector, in which you have one low-temperature water loop that is running all through the building, and then you have single rooms or say single stores, heat pumps that can take energy from the loop or can feed energy, waste it into the loop. And this way the fed and the drawn energy, thermal energy, somehow balance out into the loop. What we are doing now is to transfer this concept from the single building into the living environment, to the to the quarter and to the city level. And for doing this, what we are doing, and in particular you will see Plan Energy is doing, what we are doing, we are trying to understand what are useful topologies and sizes of the pipelines to distribute this low temperature thermal energy. And again, we are moving from, we are evaluating typical, say, topologies that are usually exploited in third and fourth generation networks, but we are looking also into possibly into using only one pipeline in the network. Next step is then to understand how to connect buildings from the production side and from the final customer, from the user side, to the network itself. And again, from the customer side, as I told you, we need some kind of a heat pump to rise the temperature level from the network to the customer to the needed level by the customer. So again, from the customer point of view, if this is representing the network, again, we are studying or we are designing solutions or substations that include for sure a heat pump and a storage, but also solutions that include a combination of heat pumps and gas boilers, as you can see, in order to not concentrate only on new build, on new buildings with an high energy standard, but also to address, say, the entire built environment, taking into consideration, therefore, also old buildings. On the other hand, we are looking into the production side. So we are looking into how we can recover waste heat from, say, different sources available along in the built environment, along the path of the network. Like they could be data centers or refrigeration systems in supermarkets, but also how to harvest renewable energy sources. I don't want to go into much details in this, but just highlighting. I just wanted to highlight the activities for now. Next step, again, as I said, is to understand how to control all this network. As you can imagine, once you move from the typical structure with one big thermal plant that is distributing thermal energy to many customers, into a situation when you have many producers with a production timeline which is not always say predictable or not always controllable at central level, you need to have a solution to or you need to have a much more flexible control solution at central level. And this is what we are trying to do with the company Anysyst, and that is developing hardware and software for this purpose. And again, if we try to make a long story short, basically what we are trying to do is to understand how to use thermal storage capacity in different ways, as I explained you at the beginning of my presentations. And when we talk about this, the main activity, and when we talk about integrating renewables, for example, like solar thermal, and the solar thermal source, we are also trying to understand how to forecast and predict, say, the thermal energy that is going to be fed into the grid in the next hours. Finally, the last point, the last activity we are carrying out is this financial assessment and business model assessment, because most of the time, from the technical point of view, solutions are feasible, but when you try to go into the financials, then you discover that barely they can land on the market, so to say. And then beside or in parallel with the technical activities, we have also this complementary task, which is about understanding which energy sources are most suitable to be integrated in this kind of networks from an economic perspective. What price should be paid for the energy that is fed into the grid, and again, what are the kind of business models and incentives that can be applied to the customers and producers that integrate that are connected to the network itself again. As I was saying, I don't want to enter into the details of the different activities. As explained, the partners, you will see 3 presentations about the topics I spoke about briefly now about. And again, as I was saying, this is a joint webinar, meaning that I presented the FLEXYNET point of view on cold district heating networks, integrated different energy sources. But again, this morning you will see also different perspectives by the project Storm and by the project h-disnet. And that is why we wanted to have them on board today. This is it from my side. I think we